Hi, my name is Takuzo Ganre. I am a former A-level student and I graduated high school with straight A stars, and I'm here to help you do the same, or if not, just make A-level maths a little less challenging for you. So in this video, we'll be looking at coordinate geometry, and we'll be focusing on the following syllabus points. Find the equation of a straight line given sufficient information. Interpret and use any forms y equals mx plus c, y minus y1 equals mx minus x1, ax plus by plus c equals 0 in solving problems. Calculate distances, gradients, midpoints, points of intersection, and use the relationship between the gradients of parallel and perpendicular lines. So a straight line is one that can be written in the form y equals mx plus c, where m represents the gradient and c represents the y-intercept. So to calculate m, the gradient, we use the formula y1 minus y2 over x1 minus x2, where the coordinates are given in the form x1, y1, and x2, y2. So apart from being written in the form y equals mx plus c, there are also other forms for writing the equation of a straight line, which are ax plus by plus c equals 0, where a, b, and c are constants, as well as using the form y minus y1 equals m times x minus x1, where m is the gradient and y1 and x1 represents the coordinates of a point that lies on the line. In this topic, you'll also be required to calculate the length of a line, and to find the length of a line AB, we use the formula AB is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. We will also be required to find the midpoint, and we use the formula m is equal to x1 plus x2 over 2, comma, y1 plus y2 over 2. Then we also need to understand what parallel lines are. Parallel lines are lines that never meet and they have the same gradient. If two lines are parallel, you will usually know by this arrow. It shows that both lines are parallel and will never meet. Perpendicular lines are lines that intersect each other at 90 degrees. Their gradients are negative reciprocals of each other, i.e. the product of their gradients is equal to -1. So if you have two lines that meet at a 90-degree angle, let's say this is line L and this is line M, these two lines are said to be perpendicular to each other since they meet at a 90-degree angle, and their gradients m1 times m2, the product of their gradient is equal to -1. So m1 times m2 is equal to -1. Now let's walk through some past paper questions and apply the concepts we've learned above. Number 1. The point M is the midpoint of the line joining the points 3, 7 and -1, 1. Find the equation of the line through M, which is parallel to the line x over 3 plus y over 2 equals 1. So let's call the line whose equation we're required to find L. We'll call that line L. And now we're going to sketch a diagram of our problem. So we have the point -1, 1 somewhere here, and 3, 7 should be somewhere here. And let's join the 2 points, and the midpoint of this line is somewhere here, and that is M. And then the line whose equation we want is the line through M, and we've said that we're going to call this line L. And then there's the line x over 3 plus y over 2 equals 1, which is parallel to our line L. So it's something like that. Since they are parallel, we can put this arrow to show that they're parallel. So this is the line x over 3 plus y over 2 is equal to 1. So to find the equation of a straight line, we either need 2 points that lie on the line, or we need 1 point together with the gradient. So in this case, we're looking for the equation of line L, and we can find 1 point, which is M, and we can also find the gradient since we know that our line L is parallel to the line x over 3 plus y over 2 equals 1. So we can use this second method of finding 1 point as well as the gradient. Our 1 point will be the midpoint, and then the gradient we can get it from the line x over 3 plus y over 2 equals 1, since it's parallel to line L. So let's start by finding the midpoint. So the formula for midpoint is m is equal to x1 plus x2 over 2, comma y1 plus y2 over 2. And if we substitute our coordinates, we'll end up with our midpoint having the coordinates 1, 4. And we know that our line L passes through the midpoint. Now we need to find the gradient. To be able to find the gradient, we know that our line is parallel to the line x over 3 plus y over 2 equals 1. So that means this line has the same gradient as line L. So to be able to tell what the gradient of this line is, we have to write it in the form y equals mx plus c, and m will be the gradient. So we can do that by making y the subject of the formula. And if you make y subject of the formula, you end up with y equals negative 2/3 x plus 2, and that means m, our gradient, is equal to negative 2/3. Now that we have the gradient as well as a point that lies on the line, we can now find our equation. So in this example, we're going to use the form y minus y1 is equals to m times x minus x1, where y1 is the y coordinate here and x1 is the x coordinate here, m is our gradient here. So we substitute that and we get y minus 4 is equal to negative 2/3 times x minus 1. Now you can leave it exactly like that, but I would advise you that you simplify to the form ax plus by plus c equals 0. And then you end up with the answer x plus 3 over 2y minus 7 is equal to 0, and that's the equation of our line L. Now let's move on to number 2. 2 points A and B have coordinates negative 1, 1 and 3, 4 respectively. The line BC is perpendicular to AB and intersects the x-axis at C. Find the equation of BC and the x-coordinate of C. Okay, so we know that our line BC is perpendicular to the line AB. So from that we can tell that the product of their gradients should be equal to negative 1. So if we can find the gradient of AB, we should be able to use this formula to get the gradient of BC. So let's find the gradient of AB using the coordinates we've been given. If we substitute, we end up with the gradient of AB being equal to 3/4. And if you substitute into the formula m1 times m2 equals negative 1, you end up with a gradient of negative 4/3, and that's the gradient of BC. Now remember that to find the equation of a line, we either need 2 points that lie on the line or 1 point together with the gradient. And so in this case, we already have the gradient. And if you remember, we've actually been given a point that lies on the line BC. So we know that B itself actually lies on the line BC, so we can use it as our 1 point. So now that we have 1 point as well as the gradient, we can find our equation. So we'll use the form y equals mx plus c, and m is negative 4/3, our x is 3, our y is 4. And if we simplify, we can find what our y-intercept is. C is equals to 8. Once you get your y-intercept, you get y equals minus 4/3 x plus 8. And now the question also asks us to find the x coordinate at C. So the question states find the equation of BC, we've done that, and the x coordinate of C. It says that the line BC is perpendicular to AB and intersects the x-axis at C. So if we are to extend this diagram, C would be this point where our line BC intersects the x-axis. And we know that at the x-axis, y is equal to 0. So if we want to find the x coordinate at C, we simply substitute y equals 0 into the equation of BC. So let's do that. So we know that at C, y is equal to 0, substitute y with 0, and you solve for x and you get x is equal to C. And the final answer is the equation of line BC is y equals negative 4/3 x plus 8, and the x coordinate at C is 6. Now let's move on to question number 3. The straight line with equation y equals x plus 3 intersects the curve y equals 4x to the power half at points A and B. Find the length of AB. So to be able to find the length, we need to first find the coordinates of A and B. And to do that, we know that these two equations are intersecting each other. So since A and B are their points of intersection, we can solve these two equations simultaneously to get the coordinates of A and B. So we're simply going to take the two equations and equate them together, and we're going to end up with a hidden quadratic. Notice how this is x minus 4x to the power half plus 3 is equal to 0, which if you look at it, it doesn't look like a quadratic, but if you simplify it a bit further and you rewrite x in terms of x to the power half like we've done here, you notice that it is in fact a hidden quadratic. If you don't know how to solve hidden quadratics, I have a video on how to solve them. The video should pop up right now in the top right, and I'll also leave a link down below in the description. Okay, so we solve our hidden quadratic and we end up with our x values being x is 1 and x is 9, and we evaluate our y values. Y is 4 when x is 1. Now let's find out what y is when x is 9. When x is 9, y is 12. Now we have the coordinates of A and B. Since we have their coordinates, now we can use the formula for length of AB to find the length. AB is equals to the square root of x1 minus x2 squared plus y1 minus y2 squared. We simply substitute in our coordinates and we get AB is equal to 8 root 2, which is our final answer. Now let's move on to question number 4. The coordinates of 2 points A and B are negative 7, 3, and 5, 11 respectively. Show that the equation of the perpendicular bisector of AB is 3x plus 2y is equal to 11. So a perpendicular bisector, there's perpendicular and bisector. Perpendicular means that two lines meet at a 90-degree angle, and bisector means it splits that line in half, meaning that these two parts would be equal. So perpendicular means it's meeting at a 90-degree angle, and bisector means it's splitting the line into two equal parts. So in this case we have negative 7, 3, that would be this point over here, and then we have that would be A, and then we have the point B, which would be 5, 11. And then they're asking us to prove that the perpendicular bisector, which is this line over here, that's our bisector, we are supposed to prove that its equation is 3x plus 2y is equal to 11. So what we can do, since it is a bisector, it means that it must pass through the line AB at the midpoint. And since it is perpendicular to AB, we know that m1 times m2 is equal to negative 1. So if we can find the coordinates of the midpoint and find the gradient of our perpendicular bisector, then we should be able to find the equation of the perpendicular bisector. So let's start by finding the gradient of the perpendicular bisector. Since the perpendicular bisector is perpendicular to AB, we will find the gradient of AB, and the gradient of AB is 2/3, and we will use m1 times m2 is equal to -1, and you end up with the gradient of the perpendicular bisector being -3/2. And then now we know that the perpendicular bisector passes through the midpoint of AB, so we can find the coordinates of the midpoint using this formula over here. And if we substitute in our coordinates and simplify, we get the coordinates -1, 7. And now we can find the equation of our perpendicular bisector. We know that it passes through the midpoint -1, 7, and it has the gradient -3, 2. If we substitute into the form y minus y1 equals m times x minus x1 and simplify, we end up with 3x plus 2y is equal to 11, and that's what we're required to prove. 3x plus 2y equals 11. So that's it for today's video. Thank you for watching. I've left a link down below in the description to this PDF, and you can access more resources on my website CIE A Level Maths 9709.com. There's also a link to it in the description. Thank you for watching.